Welcome to today's lesson. So today we're going to be looking at transformations and specifically writing rules for transformations using coordinate notation. So let's talk about first what a transformation is. So a transformation moves or changes a figure in some way to produce a new figure called the image. And the original figure is known as the pre-image. A transformation maps or moves a point P to P prime, or segment PQ to segment P prime Q prime. So just keep in mind that the start is your pre-image and the end or final is your image. So your pre-image would be A and your image is A prime. So I would definitely recommend that you write that down. Let's grab a highlighter. So make sure that you know this stuff here, okay? So write it down in your notes or anything like that. And we're going to be looking at three types of rigid motion or congruence transformations. These are translations, rotations, and reflections. And then there's also a transformation called a dilation. But that's not a congruence transformation because congruent means to be the exact same in every way. So like the same size, same shape and everything. And a dilation is going to change the size between the pre-image and the image. So, but today we're not focusing on those. We're just focusing on transformations in general and their coordinate notation. So coordinate notation is a way to write a rule for a transformation on a coordinate plane. So the notation uses an arrow to show how the transformation changes. So if I was to start here with a point x comma y, this arrow means a transformation is going to become x minus 4, y plus 5. Or I could talk about this transformation here, x comma y. Well, now x is going to be opposite and then y. Or our third one takes as a point and flips the x and the x and y values. We're going to practice some of these, so don't get wrapped up in those. We're going to practice some with actual values, okay? So perform each transformation using the indicated coordinate notation, okay? And we're going to use the point 3 comma negative 5. So 3 comma negative 5. And what we're going to do is we're just going to use that x and y value and plug them in. So this has x first, so we're going to have a 3 because that's my x. And then opposite or negative y. So y is negative 5, so opposite negative 5. So this negative goes with this one, and then y is that guy. But we know double negatives become a positive. So this answer would just be 3 comma 5. That would be our transformation. So we'll do it again with this example. Let me blow this up some. Zoom in, there we go. So 3 comma negative 5. Now we're going to do opposite sign of x and opposite sign of y. So 3 opposite is negative. And then y is negative 5, but we want the opposite of it, positive 5. So we have a few more here, 3 comma negative 5. So now what this one's saying is take opposite y first. So here's y, and I want the opposite. So negative 5, the opposite would be positive 5. And now put x second, 3. So it's okay if x doesn't start first. We just need to put the values in the right spot that it's asking us for. Now, number 4 uses some addition signs and subtraction, and we can still deal with this just the same. So I start off with 3 comma negative 5. Now it says take x and add 3. So my x value is 3 plus 3. And then take y and subtract 2. Y is negative 5 minus 2. So my new point, or my image, 3 plus 3 is 6. Negative 5 minus 2 is negative 7. So this point here would be my image. So here's this one here, number 5, 3, negative 5. And I'm going to pause for a second. I want you guys to try this. Okay, so this first one, 2x would be 2 times 3, comma, 3y, 3 times negative 5. So 6 comma negative 15. And our last example, we have the point 3 comma negative 5. Okay, that's what they said to use for all these. Now it says put y first, so negative 5, and then x comma 3. So those are how rules work. What we're going to do is we're going to look at what some of these rules do though, okay? Because each one of these rules actually does something very specific and unique to the transformation or to our pre-image. So we're going to look at how that kind of works in this next section. Oh, here we go. So normally in class what I would do is I would have you guys actually work on this together with like your table partners. We don't have that though, so I will encourage you to maybe take a few moments here and try a couple of these on your own and see if you can find out, figure them out. But I am going to go through all of them, okay? So for each transformation, complete the table here and the graph. And then describe what occurred. So use your words and phrases, okay? Just like write an English thing. So here's our first pre-image point, negative 3, 7. So what this transformation says to do is add 3 to x and subtract 4 to y. So my x value is negative 3 plus 3. That would be 0. And then my y value is 7. 7 minus 4 is 3. So that's my first image point. So now I'll repeat that process for the rest of these. So 0 comma 4, well 0 plus 3 is 3. And then my y value of 4 minus 4 is 0. And then my last point, 2, negative 3. So 2 plus 3 is 5. Negative 3 minus 4 is negative 7. So we've completed our table. Now we need to do the graph. Now I understand that you may not have graph paper at home, but most of the problems on your homework are only going to be like 5 coordinates by 5 coordinates. So if you have a printer, remember you can go back to the resources tab and print grids off. But if you don't have a printer, these should be within your ability to just kind of sketch the graph on a piece of paper so that you're seeing what's happening. It doesn't need to be perfect. But I'm going to do mine here on this coordinate plane. So I'm going to graph my image over here, 0, 3, 3, 0, and 5, -7. So I have a triangle there. And then what I want to do is I also want to graph the pre-image so I can see what is happening to this figure. So -3, 7, 0, 4, and 2, -3. So when I look for this, what I'm looking for is it shifting up, down, right, left? Am I flipping it or am I twisting it? Anything like that. So I noticed that my green pre-image triangle and my purple image triangles, they have the same orientation. So that means I'm not rotating it and I'm not flipping it because those would change the orientation. In other words, my shortest side is at the top, shortest side's at the top, that long side is on the left. Okay. So that means this must be sliding, shifting right, left, up, and down. So what I'm going to do is I'm going to just take this one point here on the corner. I'm going to just try to describe it. Describe a different color pen. And try to describe its movement. So this point here relates to this point here. They're both these kind of this right hand corner. So I'm going to go 3 right and 4 down. I'm going to check that for my other points. Can I go 3 right, 4 down? 3 right, 4 down. So it seems consistent. So I could describe this transformation as 3 units right and 4 units down. And so what we want to be noticing are any connections that we can make between what we described here and what we see in our transformation notation here. So 3 units right and 4 units down. You guys just think about that. We'll be able to get to those details later, but look for those patterns, okay? So let's look here at this example B. So now we're going to take our point and we're going to do this transformation on it. So what I notice about this is that my y values all stay the same and my x values just become the opposite sign. So if I had an x value of 4, it's now -4. And like I said, the y value stays the same, 2. Next point. X is 2, so it's going to become opposite because it's got that negative in front of x, 2. And my y value stays the same, -5. X is -1, so opposite of -1, positives. And then y is 9. So that's my table. Now I need to graph it. -4, 2, -2, -5, and 1, 9. So that's my image. Remember, image is final, and pre-image, this is your start. So let me put my pre-image on here. So now what we want to do is we want to look for that transformation to describe what happened. What we mean by that is we are looking to determine, does it flip, slide, or rotate? I guess you could also call it a twist. So to help us with this, what I'm going to do is I'm going to take the two triangles here and I'm going to just draw them out kind of separately. I'm not changing the orientation. I'm just going to draw them out separately so they're not overlapped. So when I do that, are you able to see what happens? So these orientations are different. Notice how the purple triangle is kind of pointing to the left and the green one's pointing towards the right. But they both have our long, thin sides up. So this is what we consider to be like a reflection, because I could put this line right between them, and then the purple and the green would be a reflection, like as if you were looking into a mirror. Okay. That's not how you spell reflection. Or you could also say it was flipped. And again, we're going to be talking about these things a lot more next week. So don't worry about being perfect, just look for those patterns. Okay, so this would be a really good one for you guys to pause and try to do on your own. Notice how the grid's smaller size, so it's something that you could draw on your paper. And I think the transformation is relatively friendly for you guys to be able to try out. Alright, so I'm going to go through and fill this in. So what this tells me is if I have a point x comma y, I want to put y first. So here's my point, put y first, and then I'm going to put the opposite sign of x. So x is -2, which means it's going to become +2. I'm going to repeat that process. So I'm going to put y first, so -1, and then opposite sign of x is +4, because it's a negative, so it becomes positive. So again, I'm going to go through and say put y first. So here's my coordinate point, y, and then opposite of x. 0 is not positive or negative, so it doesn't matter if it's a negative sign or not. It's just always just 0. And then I'll come over here and I'll plot all my points. So 3, 2, -1, 4, -4, 0. And then that's my final. And I'm going to plot my beginning or my pre-image. So again, I'm going to take these and kind of draw them out a little bit separate so that they're not overlapping themselves. And when I notice this, the first thing I notice is obviously they're not in the same orientation. So that means that they cannot be a slide. Okay. So slides would have the same orientation. So it can't be just like a sliding up, down, right, left. So I want to look for, is there like a line of reflection or a mirror that could happen? And when I look at this, I don't see anything like that that would make me think mirror, mirror, okay, like a reflection. Okay, so a reflection or a flip. Okay. So now I want to say, could I twist this in some way? And so actually I could. If I was to take my paper and just twist it a little one way or the other, I could actually make the one triangle look like the other one. So this we want to say that it twists. Or you could say rotates. Again, this whole thing is about, can we just use this transformation notation and to find our points? And then we're trying to look for those patterns and what's happening. Alright, so now instead of looking for the patterns and what's happening, we're going to kind of get a little bit more involved into our practice problems here. And we want to actually start kind of writing what's happening between my notations. So what we're going to do to complete the missing part of our coordinate notation for these transformations, we're going to look for patterns. So when I look for patterns, the first thing I want to look for is the relationship between the x values here. So is there any sort of relationship or connection I could make between these values? And the first thing that I would think of is, I don't know. But when I look at them, I notice that, oh look, all of these are multiplied by 2. Negative 2 to negative 4 is times 2. 0 times 2 is 0. 1 times 2 is 2. So we could call this 2x, because we're just multiplying that x to get by 2. And then after I do that, I'm going to look for, is there a relationship with my y values? So for my pre-image to my image, how do I go from 1 to 2? How do I go 2 to 4? Or negative 2 to negative 4? Well, this would just be 2y. So that would be my coordinate notation. Okay? It says I take x and multiply by 2. I take y and also multiply it by 2. So now I'm going to go ahead and plot my points and see what happens when I multiply a transformation by 2. So let's do this way. So I'll put my image in purple. Negative 4, 2. And then I will put my pre-image in green. So can you tell what happens between the green and the purple? Okay. So this here, right, it gets from green to purple, it gets larger. So we're not looking for anything super specific, just a general explanation of what happened. It gets larger. Okay, so what if I have this one? Notice that this is a forwards transformation, but it's giving me the end, the image points. So to go backwards, right, what we want to do is we want to do the opposites. If going forwards I subtract 6, then going backwards I want to add 6. Forwards I add 10. So going forwards we add 10. Coming backwards we want to subtract 10. So now we're going to do this with all of our image points. So x values add 6. 4 plus 6, 10. Y values subtract 10. 6 minus 10, negative 4. X values, so 2 plus 6, that's 8. And then 10 minus 10, because remember we're going backwards here. And then the last one, -3 plus 6, 9 minus 10. So this would be my pre-image, and then these are my image. I'm going to erase these values just so we don't get confused when we're graphing it. Alright, so I'll go ahead and I'm going to graph. So I'll keep my pre-image in green. And then I'll do my image in purple. And we want to check to see, does this agree with the fact that we moved left 6 and up 10? So I start with my pre-image, and I go to my image, and I say, yeah, I want it to go up 10 and left 6. So we're all set. We did it right. Okay, so on this one here, we need to find the relationship between these and then write the coordinate notation. So again, if I'm trying to write the coordinate notation, I want to look for any pattern I can find. So when I look at my x values, 1 to 1 does nothing, right? But 1 to 4, well, that could be adding 3 or multiplying by 4. And 5 to 2 doesn't match any of those. So that's not helping me. But what I do notice is over here on my y values, those match my x values, except I have these negative values here. So instead of calling this x, this would be like a, oops, I don't want a highlighter. This would be like a negative x. So this here is negative x, and then I want to try and look for a pattern for my y values. Well, oh my goodness, I see a y value right here. And those are the exact same. So I can write that as just y, because those values match. So my rule would be y comma negative x. And then what I would want to do is I want to plot these points. So one of them's already plotted for me. So let me check my image. So 1, -1, 4, -1, and 2, -5. So that's my image. And then I can also do my pre-image. 1, 1, 1, 4, 5, 2. And that there would be my pre-image. So now what I can do is I want to look for any changes in this. What I notice is there's no orientation similarities. The arrow here is pointing towards the right, whereas this one's kind of pointing more downwards. So it's not a slide, because slides have to have the same orientation. I wonder if I can find like a line where it would flip or reflect over. But when I look for those, because the line would have to be in the middle between them, I'm not seeing anywhere that I could draw the line. So this must be a rotation or a twist. So this would be a twist or a rotation. That's not how you spell rotation though. Okay. So this is our last one. So it already tells us that this is flipped over the line y equals x. So just so you guys can see this, the line y equals x would be this line here. So that's what we would call the line of reflection. So we're flipping over that. But it gives us both the image and the pre-image. So what we need to do is fill in our table first. So this says my pre-image has an x value at 2. 2, and I see a point at x equals 2, and it's at 1. So my y value is 1, and I'll color that in. And then I'm going to fill in the rest of these points. So 4, -3. And then I need to do this one, -2, -5. And now I'm going to go ahead and do my image. So 1, and that points at 2. And then -3, 4, -5, -2. Now the only thing left to do is we need to find a coordinate notation to describe this. So what pattern can you notice between these columns of my tables? Did you notice that my x values went here and my y values went here? They just flip-flopped spots. So this is, oops, this is x and this is y. So my coordinate notation is y, comma, x. So just to kind of list some of the things that we maybe need to keep in mind as we're doing our homework. So let's put our points to remember. Pre-image to image. Or in other words, start, end, or final. And that's really important when we get into our other transformations and looking at them specifically. And then we also have coordinate notation. So x comma y goes to something in there. Okay. And things that you want to be looking for is, can I add or subtract? Can we multiply or divide? Or do they switch places? Those would be the first things to look out for. And I cannot speak and write at the same time. So that's what I would be looking for as I was to do this. And then when you're describing these, right, we can describe things as slides. Right, and we could say right, left, up, or down. We could say that they flip or reflect. And we also have the twist or rotate. So today is just about looking at transformations very generally and really getting a hang of the coordinate notation and making the tables and trying to get some graphs done. And so that's all for today's lesson.